Welcome to tonight's video on Unit 5, Topic 1, Graphing Rational Functions. So first, in order to graph rational functions, we have to talk about how to find the domain of a rational function. To find the domain of a rational function, remember, rational function means fraction. So to find the domain, remember, fractions, the only numbers they can't be are what makes the denominator equal to 0. So in order to do that, we're going to set the denominator equal to 0. So for example, here we go 3x plus 5 does not equal 0. So subtract 5. So you get 3x does not equal negative 5. X does not equal negative 5/3. So that means the domain is from negative infinity to negative 5/3, union negative 5/3 to infinity. Right? So basically what we're saying is all real numbers except negative 5/3. That's why you put the parentheses around negative 5/3 instead of the brackets. So for the next one here, x squared minus 25 cannot equal 0. So there's two ways that you could do this. The easiest way is to move over the 25 and then take the square root. But remember, when you take the square root, you have to put plus or minus on the right-hand side. So it's can't equal plus or minus 5. Now for this one, if you look at it as a number line, so basically it can't be 5 or negative 5, but it can be everything else. And remember, negative infinity is here and positive infinity is here. So it can be from negative infinity to negative 5. And then between negative 5 and 5. And then from 5 to infinity. So here when we factor, remember when you factor 3x squared minus 4x plus 1, you multiply the first and the last, and you say what are the multiples of 3 that add to negative 4, and they are negative 3 and negative 1. So to do this, I like to, since this is a 3, I'll say it's 3x minus 3 and 3x minus 1. And then I divide by a common factor. Here there's 3. Here there is not a common factor. So it's x minus 1 and 3x minus 1. So you get x cannot equal 1 or x cannot equal 1/3. So when you do the domain, it's from negative infinity to 1/3. 1/3 union 1/3 to 1, union 1 to infinity. Here, 2x minus 3 cannot equal 0, so that means 2x cannot equal 3. X cannot equal 3/2, so the domain is from negative infinity to 3/2, union 3/2 to infinity. The next one, x squared plus 16, well, this is never equal to 0, right? Because if you try to set it equal to 0, right, you get x squared cannot equal negative 16. Well, you can't square a number and get a negative. So that means the domain is all real numbers because there is no number that makes it equal to 0. Here on the bottom, 4x squared minus x minus 3 cannot equal 0. So the factors of negative 12 that add to negative 1 are negative 4 and positive 3. So here when you divide by 4, you get x minus 1 and 4x plus 3. Those cannot equal 0. So x cannot equal 1 and x cannot equal negative 3/4. So when you do the domain, it's from negative infinity to negative 3/4, union negative 3/4 to 1, union 1 to infinity. That's the domain. All right, so why is it important to know the domain? Well, the domain can tell you where you have what are called vertical asymptotes and or holes in the graph. A vertical asymptote is, you have a vertical asymptote for the graph if the function increases or decreases without bound as x approaches a number. Well, how do you tell? Well, if you simplify the function, so if you factor both the numerator and denominator, notice here the x plus 2 is left. So that means at -2, there is a vertical asymptote, and any factors that cancel, like here the x minus 1 cancel, that will give you a hole, right? That'll give you a hole, and you have to then plug into the simplified version to find the hole. So here, we already know that x cannot equal -5/3, and since nothing can cancel, that means there is a vertical asymptote at x equals -5/3. Here, remember we said x cannot equal -5 or 5, right? So those are the two numbers. Now, if we simplify, right, because if we factor here, we get x minus 5, x plus 5. And we simplify, notice you're left with 1 over x minus 5. So the -5 restriction canceled out, but the +5 stayed. So that means there's a vertical asymptote at x equals 5. However, there would be a hole at, and now it's -5, but then when you put -5 in here, you get -1/10. So that will be the y-coordinate of the hole. So there's a vertical asymptote at +5, because that would make this equal 0, but then the hole would be at -5, -1/10. Here, when we found the domain, we said that x cannot equal 1/3 or 1. And neither of those would cancel, right? Because there's nothing to cancel with. So then there is a vertical asymptote at both x equals 1/3 and x equals 1. So now for number 10 here, if I factor the numerator, so 2x squared minus x minus 3, that factors, the factors of -6 that add to -1 are -3 and +2. So you get 2x minus 3, 2x plus 2. So that means when you divide by 2 here, so when you factor the numerator, it becomes 2x minus 3 and x plus 1. So notice this cancels here. So you're left with just x plus 1. However, you knew from the denominator that x could not equal 3/2, right? Because that's what would happen if you set 2x minus 3 equals 0. So when you put 3/2 in, so 3/2 plus 2/2 would give you 5/2. So the whole would be at 3/2, 5/2, right? Since the restriction canceled out when you simplified it. Now here, remember, we can't factor x squared plus 16, so there will be no vertical asymptote or hole, right? Because nothing cancels out in the denominator, since we can't factor that. Here in number 12, 4x squared plus 11x plus 6. So here's the factors of 24 that add to 11 are 8 and 3. So you get 4x plus 8, 4x plus 3. And notice there is a common factor here of 2, actually of 4. So this becomes x plus 2. Here there is no common factor, so it stays at 4x plus 3. Then here, 4x squared minus x minus 3. If you go back up to here, we factored this to x minus 1 and 4x plus 3. So when we look at this, m of x is equal to x plus 2 times 4x plus 3 over x minus 1 times 4x plus 3. So you cancel here. Now understand, if you set these equal to 0, you get x cannot equal 1 or negative 3/4. Now you cancel here and you get x plus 2 over x minus 1. So that means there is a vertical asymptote at x equals 1. However, there's going to be a hole at negative 3/4, and now we have to put in the negative 3/4. So negative 3/4 plus 2 over negative 3/4 minus 1. 2 is going to be 8/4, so that gives us 5/4. And then this is 4/4, so negative 3 minus 4 is negative 7/4. And remember, when you divide fractions, you multiply by the reciprocal. So it's going to be negative 5/7. So that would be the whole. All right, so now that we know how to figure out where a vertical asymptote is and where a hole is, we have to use this to graph the functions. Now first, there are such things that are called horizontal asymptotes. And horizontal asymptotes tell you what the graph will do at the end, the left and right hand behavior of the graph. So as x goes towards infinity, which is to the right, or to the left, it'll tell you the number that the y values will go to. There is a procedure here to find a horizontal asymptote. So there's 3 situations. If the degree of the numerator is less than the degree of the denominator, and what I mean by degree is the power of x. So like if you had x squared plus 3x plus 4 over x plus 1, the degree of the numerator is 2, that's the highest power of x. The degree of the denominator is 1. So this would not be that situation. So if the degree of the numerator is less than the denominator, so like for example, if you had x plus 2 over x squared plus 3x plus 4, then the horizontal asymptote is automatically y equals 0, the x-axis. That would be the horizontal asymptote. If the degree of the numerator and the degree of the denominator are the same, so for example, if you had x to the third plus 3x plus 2 over 2x to the third plus 1x plus 5, then what you do is you divide the leading coefficients. So here the leading coefficient is 1, here it's 2, so the horizontal asymptote for this one would be 1/2. So you divide the leading coefficients. If the degree of the numerator is more than the degree of the denominator, there is no horizontal asymptote. So see how here the degree is more than the denominator. However, there is what's called a slant asymptote, and we'll talk about that later. So if you look at this equation here, the degrees are both 1, right? So what you're going to do to find the horizontal asymptote is divide the leading coefficients. So the leading coefficients are 4 and 3. So the horizontal asymptote would be 4/3. Here the degree is 1, here the degree is 2. So since the degree of the numerator is less than the denominator, that means the horizontal asymptote is automatically y equals 0. Same thing for number 15. Notice number 15, the degree is 0 and the degree is 2. So the numerator is less than the denominator as far as the degree. So therefore the horizontal asymptote is y equals 0. Here they are the same degree. They're both 2. So therefore you divide the numbers. So the horizontal asymptote would be at y equals 2 over 2, which is 1. Here, the degree of the numerator is less than the denominator, so horizontal asymptote is at y equals 0. And here, notice the degrees are the same, so the horizontal asymptote is at y equals negative 4/3, right? 4 over negative 3. Now, if the degree of the denominator is more than the numerator, then you have what's called a slant asymptote. And to find a slant asymptote, you can either do long division or synthetic division depending upon what the degree of the denominator is. So, for example, here, when the degree of the denominator is 3, then we have to do long division. So we would say, okay, there's no horizontal asymptote because the degree of the numerator is larger than the denominator. But to get the slant asymptote, we're going to have to do long division. And since it skips powers, remember we have to put zeros. So here it'd be x to the 4th plus 2x to the 3rd plus 0x squared plus x plus 1. So we're going to divide the denominator by the numerator. So notice x to the 3rd times x will give you x to the 4th. So then we multiply. And notice we subtract, so that's going to cancel here. 2 minus 0 is 2. 0 minus 0 cancels out. And then x minus negative x, so that's x plus x, so that gives you 2x. Then we're going to bring down the 1, and we're going to do the same thing. Now x to the 3rd times 2 gives you 2x to the 3rd. And then this will be minus 2. So then you're going to subtract 2 minus 0, 2x, and then plus 3. So the remainder does not matter in synthetic division as far as finding the slant asymptote. The slant asymptote is the quotient. So the slant asymptote here would be the line y equals x plus 2. All right, so kind of like above here, we got x minus 5, right? So notice this line here, x minus 5, that would be the slant asymptote. Now, here, notice the degree is 2, degree here is 1. Now, this is a first degree. So first degree, you could do synthetic division. So you could put 1 in the box. And then you would go 1, 0, 1, because there's 0x. Bring down the 1. 1 times 1 is 1. Add down. Multiply. Add down. So remember, this is the remainder. So your slant asymptote here since this was second degree, this is going to be y equals x plus 1. So that would be your slant asymptote here. Here, notice the denominator is first degree, so we could do synthetic division again. So we go 2, negative 5, 7. Bring down the 2. 2 times 2 is 4. Add down. Multiply. Add down. So remember, this is the remainder. For the slant asymptote, the remainder doesn't matter. So here the slant asymptote is at y equals 2x minus 1. All right. So that's how you find a slant asymptote if there is no horizontal one. So now, how do we graph a rational function? Well, there's a process. Okay, there's a process. So let's do step by step. So the first thing we're going to do is we're going to factor the numerator and denominator completely. All right, well here they're already factored, and we're going to simplify if possible. Remember, if you cancel a factor, that gives you a whole. So notice, if there's a factor left in the denominator, which there is here, that would give you a vertical asymptote. So let's set 3x minus 7 equal to 0. So that means the vertical asymptote is at x equals 7/3. Determine any wholes. Did any factors cancel? Well, we didn't cancel anything here, so there are no wholes in this case. Determine any horizontal asymptotes or slant. Well, so if there is no horizontal, there's going to be a slant. But here, the degrees are the same. They're both 1. So that means the horizontal asymptote, you divide the leading coefficients. So the horizontal asymptote is y equals 2/3. There won't be a slant asymptote because there's a horizontal. There's going to be one or the other. There can't be both. X-intercepts. So you set the equation equal to 0. Now remember, the only way a fraction can be equal to 0 is if the numerator, so really the x-intercept is what makes the numerator equal to 0. So the x-intercept is 11/2, 0. The y-intercept, when you put 0 in for x, so it's a -11 over -7, so it's 11/7. So the y-intercept is 0, 11/7. And then we're going to use the information to graph this. So first, let's put the vertical asymptote, which is 7/3. So 7/3 is 2 1/3. So here's 1, 2, 1/3. So let's put that right here. And then as far as there's no holes, the horizontal asymptote is at y equals 2/3. So y equals 2/3 is almost 1. And then the x-intercept is 11/2, 0. So basically 5 1/2. So 2, 3, 4, 5 1/2, 0. And the y-intercept is 0 11/7. So it's about 1 4/7. So it's about right there. So notice it says you must have one ordered pair label on the graph, and you have to have one. If you look at the vertical asymptote, you have to have one ordered pair on each side. So since we have that, what we can do, because the vertical asymptote, the points are going to go towards the asymptote. So it's going to go towards the asymptote this way. It won't touch it. And it's going to go towards the asymptote this way, and it's going to go out. So same thing here. It's going to go towards the vertical asymptote and towards the horizontal. So they look like branches. But they come close to the asymptotes, but they never touch it. And that is what your graph will look like. Let's try again. So here we can factor, right? This is 3 times x minus 1. And this here is x minus 2 times x minus 1. Right? So now, notice we factored and then we simplify, right? So that means it's equal to 3 over x minus 2. So notice the vertical asymptote would be at x equals 2, right? Because that was the one that was left. We did not cancel from the denominator. The whole, well, we canceled the x minus 1, so the x coordinate would be 1. And when we put 1 in, 3 over negative 1, which is negative 3. So the y coordinate of the whole would be negative 3. Now, horizontal asymptote, well, if you look, the degree of the numerator, and you use the simplified version, the degree of the numerator is less than the denominator, so the horizontal asymptote is at y equals 0. And the x-intercept, well, if the horizontal asymptote is at 0, that means there is no x-intercept, right? Because if you look at 3 over x minus 2, if you set that equal to 0, right, 3 does not equal 0, right? So there's no x-intercept, meaning it doesn't touch the x-axis, and that means that that is true because the horizontal asymptote is the x-axis. The y-intercept, on the other hand, if we go f of 0, well, 3 over 0 minus 2, so it gives you negative 3 halves. Right? So now we know that there is a vertical asymptote at x equals 2. Horizontal asymptote is the x-axis. I'll just put a dotted line over it. Then we know there is no x-intercept, but the y-intercept is 0 and negative 3 halves. So here's 0. Now notice we only have a point on this side of the vertical asymptote. We need one over here. So choose a number that is bigger than 2. So I'll choose 3. So if I put 3 into the function, notice it gives me 3 over 1, which is 3. So the point 3, 3 is on the graph. So that tells me where the branches go. There's one branch here through the y-intercept, and then there's a branch up here that goes up this way and then down towards the horizontal asymptote. So let's try another one. So now here, notice if you factor, this gives you x minus 3 and x plus 3. So notice there are 2 vertical asymptotes because nothing cancels at 3 and x equals negative 3. There's no hole since you didn't cancel anything out. Now notice for the horizontal asymptote, notice the degrees are the same, so the horizontal asymptote's at y equals -2. The x-intercept, right? Well, if you set 0 equal to -2x squared over x squared minus 9, notice basically -2x squared equals 0 when x equals 0. So it's 0, 0. Which means the y-intercept, when you put 0 in, notice you get 0 over -9, which is 0. So both the x and y-intercept is 0, 0. So we're going to use the information above. So we had asymptotes at vertical asymptote at -3 and 3. Horizontal asymptote at y equals -2. We had the y and x intercept at 0, 0. So we know a point here. However, we don't know a point on to the left of -3, and we don't have a point to the right of 3. So what you want to do is put in -4, because that's the next one over. So -4 squared is 16 times -2 is -32. 16 minus 9 is 7. So basically this would be -4 and 4/7. So when you put in -4, you get -4 and 4/7, so somewhere around there. And then when you put in +4, because that would be the next number over from 3, notice you get the same thing, -32 over 7. So notice it would be right there. So when you graph this, keep in mind that it goes towards, so it's not going to go down because there's nowhere for it to go. This asymptote's here. So it's got to go up this way and then up that way. So it's a parabola in the center. And then this has to go towards the asymptote there and towards the asymptote. Same thing here. There we go. All right, last one. Notice this one, we can't factor the denominator, but we can factor the numerator. But notice when we factor the numerator, nothing cancels, right? So there is a vertical asymptote at x equals 2. There's no hole. There's no horizontal asymptote because the degree of the numerator is larger than the denominator. But there is a slant asymptote, and if we do the division, we divide 2, 1, -3, -4. We can do synthetic division because it's a first degree in the denominator. So bring down the 1, times 2, add down, multiply, add down. So notice the remainder is -6. That means the slant asymptote is y equals, since this is second degree, it's going to be x minus 1. Finding the x-intercepts, that means you're setting it equal to 0. So that means set the numerator equal to 0. And notice the factors of this are x minus 4 and x plus 1. So that means x equals 4 and x equals negative 1. So the x-intercepts are 4, 0 and negative 1, 0. The y-intercept, when you put 0 in, you get negative 4 over negative 2, which is 2. So that's the y-intercept. So let's use the information to start graphing it. So there's a vertical asymptote at 2. The slant asymptote is at x minus 1. So graph the line x minus 1. So you start at negative 1, and you go up 1 over 1, up 1 over 1, up 1 over 1. So make a dotted line there. So the slant asymptote is just a diagonal line instead of a vertical or a horizontal line. So this is y equals x minus 1. That's your slant asymptote. So then the y-intercept is at 0, 2, right here. The x-intercepts are negative 1, 0, and 4, 0. So notice we have on each side of the vertical asymptote, we have points. Sorry, I misplaced. I put it at negative 2 instead of 2. I knew something looked off. All right, so here, this goes up towards the vertical asymptote. Then it goes down towards the slant. And then here it goes down towards the vertical asymptote and up towards the slant. And there you go. There's our graph. All right, so that concludes topic 1. So now you should be able to do the webathon. And if you have any questions, feel free to contact me. All right, have a good rest of your evening.